You're given two non-empty linked lists. I don't think TypeScript helped us here, so we're going to do JavaScript. Two non-empty linked lists, so L1, L2. The digits are stored in reverse order. Each of their nodes contains a single digit. Add the two numbers and return the sum as a linked list. You may assume two numbers do not contain any leading zeros except the number 0 itself. Okay, sure, that makes sense. So we kind of need to understand this data structure because it's not really a standard JavaScript data structure. So we need to know, okay, so it's not really a linked list. Yeah, it's not really. Is it? I mean, the way they put it here doesn't make it seem like it's actually a linked list. The only problem is I don't understand. Oh, wow, okay. So they kind of define. I don't know why they commented this. This is important code. This is something that you should just be using. I guess the first node, the digits is stored in reverse order. So the first node, 243. This is the 110, 100. 110, 100. Okay. So my first instinct, we need to go through all the nodes anyway, so we might as well simplify the problem. So my first thing would be to create a function. And it'll be node.val plus 10 times convert to number node.next. Yeah. Something like that. And then we say const a equals convert to number L1, 2, and then we have to say return convert to list A plus B. We'll say convert to list equals number. Here we gotta say if not node return 0. So do we have a base case? And in here, convert to list. So the first number is, so The easiest thing to pull out is the tens, or the ones place. But the ones place is the first element. So I think we say const node equals list node. The value is const val equals number mod 10 const next equals convert to list. I guess this should be previous. I think this needs to be next. And I think we need to say convert to list. And this will be number divided by 10 Lord. And it'll be this. And the list node is next. And we'll return this. And I guess if number, if not number, return next. Something like that. So the idea essentially is the first number is the ones place. The first number is the ones place, looking at these examples. So to convert it to a number, we look at the first node and add it to 10 times the next node. Essentially treating this as the ones place and the next thing as the tens place. And it'll iteratively do this and place out all the placements it's meant to. I'm kind of curious how it works iteratively, because as it goes deeper, it should be multiplying by more than 10, in my opinion. So I think we need to do like a power equals 1. And this needs to be power. I think this needs to be like mult equals 10. This would be mult. And this would be mult times 10. So as we go deeper, the number needs to be multiplied by a bigger number to represent the higher placement of the number. Similarly to how this works, every time it goes deeper, it gets divided by 10. So we convert both of these to numbers, and then we convert it back to a list after we add them. And basically, it will take the ones place and make it the next thing, essentially making, I did it backwards, I think then. The ones place needs to be the first thing. So, damn. I don't think this needs to take next. I think list node takes convert to list as next. And this returns null if there's no number. So and then we need a return. So basically the first node that we see is the ones place. Yeah, that's what we see here. And then the next node is the tens place. That's really as good as it gets until we run it, I guess. Okay, so we got no output, which is interesting. I think we could put new here. Okay, at least we got output. So something went wrong to where we didn't add something correctly. So yeah, let's take this, go to our console, and we're gonna do console.log A and B just to see what we're getting here. And we'll try to give it the same. Oof, it's a little hard to give it that input though. When we run it here, does it log at all? Okay, we do have std out. So we do see that these numbers, we have 3042 4065. So somehow there's like these zeros sneaking in here. Otherwise, they are correct. So converting to numbers, something funny is happening there. We just got to figure out what it is. Three, four, 2 4 6 5. Are any of them passing? No. Oh, interesting. The zero is output 0. Oh. We'll do this just so that that base case works. Because when we do 0, 0, when we get into here, it ends up being, we end up being saying if it's not number, we return null, but it should be an array of the number 0 at the very least. So at least this should fix one test case. Never mind. New list node 0. Okay. Okay, we fixed that case. Yeah. Something is going off as we make these numbers bigger. Something's going wrong with this multiplication. So I guess I could do console.log node.val mult just to see what is potentially happening here. Okay, so we get 2, 10, 4, 100, 2, 4, 3. There's this thing that gets multiplied. So like, should this be 1 initially? I don't think so. Because now we just get 78, which is no good. So it's definitely not that. I think at the very least, there's nothing wrong with how we convert to a list. It's the issue is how we convert to a number. So let's do result. We'll say const result. And we'll say val equals node. Actually, we'll just do node result and mult. And run it. And let's take a look here. So the node is 3. So kind of surprised that it just prints like that, but I guess there's a little bit more to it, but that's fine. So yeah, the first thing we do is go as deep as we can, which we get to the 3. Oh. Go deep as we can. Two, 4, 3 should become 342. So, I think, am I multiplying the wrong thing here? I think I might need to do this instead. I think that might be helpful. And then this should be 1 initially. Okay. Because again, the deeper we go, that's the bigger the number. So we go recursively first in order to get as deep as we can go. And then we get the number and multiply it by the mult. And initially, it should just be multiplied by 1. So we can get rid of these logs. And is there a way to optimize this? The best you could probably do is reduce it by a few points. It reduces the complexity a little bit. In theory, you could try to avoid converting here. Avoid converting to numbers and figure out the length. But I don't know. I think that you can, like, this is just ON, right? This is just ON. And then this is big ON. And even this maybe can be like 2n, but big O2n is big ON. And so this is just like plus plus plus. It's just big ON. It's really hard to do better than big ON, especially in this scenario. So ultimately, that's the best that we can do. This is optimized. So we'll go back to the problem list and do the next medium. Given a string S, find the length of the longest substring without duplicate characters. The answer is ABC with a length of 3. Note that BCA and CAB are also correct answers. So we're just giving the length. UVE, the answer is 1. The answer is WKE. Okay, I'm without duplicate characters. Okay. So we're looking at a slice of the string and find. So we're looking at a slice of the string and figuring out which one is the longest without duplicate characters. Okay. This one's a hard medium, I would say, for sure. This one, I'm trying to think of a dynamic programming solution to this problem, because I don't think it doesn't seem as simple as so like a simple solution to me, and probably why this is considered medium is just to go through the whole string. I would kind of just want to figure out why wouldn't this work? Why isn't this good enough? Pretty much we'll have like a let max equals 1. It's guaranteed 1. Well, it could be 0 if the string's length is 0. And we'll return max. But to me, like, I don't know why you wouldn't just like, this is like the naive simple solution, n squared. But you would do j equals I plus 1, j is less than s dot length, j plus plus. I think we would put j on the outside. And we'll say if s, we gotta have it like, we gotta keep track of what we've seen so far. And we'll say, we'll just put an empty if block here, and we'll say scene say letter equals S sub J. Here we'll say, can we just do a new set? I'll say scene, so for dot add S sub I, S sub J. If scene so far dot has S has letter, break. So far dot add S letter. And then we'll say max equals math dot max of max or J. Pretty much we're gonna go character by character and just go until we find a duplicate. That's the idea. N squared is the complexity. This is N. This is N, big O. The worst case scenario, these are N. Since N is nested in N, big O is N squared. And I'm just, if anything, I got the set functions wrong, but we could just run it, see where we fail. If it has letter. So somehow we got 8. Let's see. If it has the letter, we'll break out that and set the J. Oh, it's gotta be, sorry about that. It's gotta be J minus I, because this is how many characters we've gone since the duplicate. Otherwise, J will eventually be 8, and just having J there would be wrong. So that does work. It's N squared. Is there a challenge? There's no extra challenge. But the question is there a way to make it better? Usually dynamic programming, it helps you to solve unsolvable problems or solve problems in N squared. So I don't see how we can get better than N squared, but let me think on it for a moment. Okay, so one thing that kind of makes me wonder, what we could do is some kind of a map where we track the last time we saw a number. Something like that. There's got to be something to where every number, every character will like keep track of how many characters we've seen. We can go through the loop and we could track, okay, if the first character is this, how many characters until we see that character again. And we could do that for each item in the string. Basically incrementing the values of previous items until we get a max. I can't really explain it super clearly it's probably easier to write it in code. But basically the idea is we have like some kind of, so let's optimize. We have some kind of tracking. And that is basically like an array dot, where the length is s dot length. And we'll say fill 0. I think this is code. Let me just replace. Is it? Interesting. Okay, well, I guess I don't know how to. Oh, okay. Never mind. I'm writing the wrong code here. I'm just gonna put 5 here. I don't know why I'm making it complicated. Okay. Yeah. So basically what I'm doing is I'm keeping track of how each index is doing. How many characters have I seen without seeing the same character again? And I'm going to go through the whole string, of course. And I think what we're going to do is return, we're going to have math.max tracking. And we also want to keep track of the last time we saw a character so that we can reset it, essentially. So we're gonna, yeah. Okay, this is a cool idea. I like this. We're going to say, initially we're going to get the letter, sub I, and we're going to see, have we seen this character before? Maybe, I don't know. Do we even need to do that? I don't think so. I think we just say like last index sub letter equals I. And then after that, we can go through every single, it's kind of n squared still. It feels like it's still n squared. Let me just write the algorithm, just so that maybe there's something I'm missing. Maybe it doesn't even work. Because as far as I'm concerned, we're still gonna have to do for we'll do, well, we have to do this for const key in last index. I think I just say indices object dot values. And we say tracking sub index plus plus. So basically, going to the index of every letter we've seen so far, incrementing it by 1 if we haven't seen that letter again. That's basically the idea. But in practice, I'm not sure that it works. We can run it, see if there's any validity to this attempt to optimize. So we got an output of 8. So let's think about this a little bit. S sub I, last index of letter. So like, I think we could do console.log tracking here just to see if things are resetting properly. If everything's 8, then something's going wrong. Okay, so the question is, why is it? Let's also do last index, because the last index of A should be like 0, 1, 2, 3. So let's make sure those are occurring correctly. So that is the case, but somehow it still has an 8 here, which is curious. Oh, I mean, the first 3 are, for some reason, the largest, when they should not be. They should stop increasing at a certain point. Because the idea is when I see the letter, the last index of the letter should change, which it does. We see the A3, B7, C5. That is the last time we see each of those indices. And then we should be going through those indices 3, 7, and 5 at some point, and only incrementing those for tracking. So yeah, it's a little confusing as to why it wouldn't work. So only thing we could do really is I guess log last index every time. Just to see what the value looks like. So this looks the way I would expect it to look, at the very least. And to some extent, I would expect it to operate faster than this code does. Like this code is almost guaranteed n squared. I mean, I don't know. Maybe they're just as likely. Let's see. Okay, how about we'll print both. Okay. This should hit 3, that should hit 2, that should hit 1. And A has officially become 3. So I guess let's print values. printing values. Yeah, okay. It's 3, 1, 2, and yet, oh my gosh. It's gotta be of. It's gotta be of, because this would get an actual item from this array rather than the index of the array. So I just had the wrong keyword here. This should work now. I mean, if it was meant to work, it should work. Apparently it's not meant to work though. So back to logging. And we'll run. We'll see which of these items is 5. So it's A, B, C, A. And A, B, C, because it's not about, okay. It's not about seeing this character again, it's about seeing any character again. Okay. So that's something that I overlooked when writing this algorithm. Um, I was so focused on the first character being unique, I stopped caring about the fact that every character in the sequence needs to be unique. So after all of that, you can't optimize. I can't. I mean, I can't optimize it. This seems to be as good as it gets because you need to keep track of what you've seen so far per character. So yeah, I just don't think that you can optimize beyond this. I know it's not like efficient, but this is as efficient as it gets for this kind of problem. So I think I'm just realizing that I'm not submitting. I'm just running it. So I need to go back and submit all of these. So let's submit. Let's go back through all of the problems we solved so far and submit it. Okay, we did pretty good on this one. And yeah, let's look at the submissions. We didn't do that good on this one, which makes me think that there is an optimization. But that's okay. All right, let's find the other one we did. Let's submit it. Okay, we did all right. Then is that everything we've done so far? Do some. Add 2 numbers. Okay, we didn't submit this. Oh. Seems like this doesn't even work. Yeah, this doesn't even seem to work. Which is curious. Okay, we'll have to come back to that then. This one. We did this. Oh, we did all right here. feel like the memory is unfair. I wish it would check things off though. We did these easies. Mhm. And medium. What was the other medium we did? Okay, this one. I mean, supposedly it doesn't even work. Okay. Why doesn't it work? That's the question. We do get a big number. Is it related to? Actually, we failed 3 test cases. So my first question is it related to the fact that we don't process it in a nice way? In a nice way. That's pretty clear. All right, so we didn't really care about optimization, but if we reread the question, the 2 numbers do not contain any leading zeros except 0. Okay, so again, if we read the number, read the first number is the ones place. So it kind of makes it easier to sum it together. So we can get rid of this code for now, I think. And what we can do is just say return sum of L1, L2. And this will be the optimized version. We'll say sum node 1, node 2, and we'll say const value equals node 1 dot val plus node 2 dot val. We'll say if not node 1 and not node 2, return, and we'll use some shortcut syntax just in case one side has a node and the other side doesn't. And then we'll return new list node value, and then it'll be the sum of node 1 dot next and node 2 dot next. So the first node needs to be the ones place. The other thing to consider is carrying. By default, we carry 0. Const carry equals math.floor value divided by 10. And then this will be carry plus carry. Put this here. some new lines. Okay. So basically, if we don't have a node 1 and a node 2, we should stop. If and then we'll sum node 1's value with node 2's value plus the carry, give us a value. The value is just going to be the tens place. That's all we care about. And then we'll carry over anything greater than 10. And using the next to next. So that should be good. I did not put question mark here. We're here. Try it again. I did not put a question mark here or here. Try again. Okay, so there's test case 3 is failing. Output is strange. Not strange. It's just seemingly off by 1. Ah. Because there's a carry. Okay. That's an interesting problem. So I guess not carry as well. Okay. Let's run that. Oh wait, we ran it. That seemed to work. Let's submit this. All right, that worked. And it did pretty nicely compared to other solutions. Okay. Let's look at the problem list. All right, we're starting to get our check marks. So we have the 3 easies, we have 2 mediums done. Yeah, let's do longest palindromic. We already did palindrome though, so I might skip that for now. Let's do ZigZag Conversion. Okay, the string PayPal is hiring. Oof. Is written in zigzag pattern. On a given number of rows like this, you may want to display this pattern in a fixed font for better legibility. PayPal is hiring. Okay. And then read it line by line. Write the code that will take a string and make a conversion given a number of rows. What? String that will take a write the code that will take a string and make this conversion given a number of rows. So the input is PayPal is hiring, number of rows equals, then that becomes, okay. So we need to move, okay. And I'm assuming that if there was another character, it would go here and we would just keep doing that. Depending on, and then if it's more rows? Oh. Oh. Oh, I see. I didn't even understand what it wanted at first. Okay. This is even crazier. Hmm. All right, this is an interesting problem. Very unlikely problem, but interesting. Um, so for me, first thing I'm thinking of is going row by row, column by column, letter by letter, and processing this string until there's no more characters to process. So I think it's going to require 2 for loops. All right, so basically I'm going to do 2 for loops. The first for loop will go draw everything top to bottom. The next for loop will do the diagonal. Next for loop will do top to bottom. Next loop will do the diagonal until there's no more characters. So basically, while while let I equals 0, I is less than s dot length, and then we'll do something where I plus plus. And so for let j is less than num rows, sorry, equals 0. J is less than num rows, j plus plus. Excellent. So this is going to be top to bottom. And then we're going to have like const output equals an array. And it's going to be, I want to do this as a double array. So, excuse me. I think every time we're about to do one of these loops, we need to say output dot push array dot from length num rows dot fill empty string. And then we'll say output sub I, no, output sub, okay, we need to keep track of the column, I guess. Output sub column sub j equals s sub I plus plus, and then column plus plus. So we basically do all of this to set up that first zig, I guess, and then we'll do the zag. So zig, zag. Now for each iteration, we need to go up and write one. So for let j equals 0. And we basically go 2 less than every row. So if the rows are 4, we only go 2. So j is less than num rows minus 2 j plus plus. And we're going to do this again. We're going to create the column. I'll just call this columns, I guess. Output is columns, and the row is going to be row num rows. Do we even want to do this? We could just make it j. It'd be easier. We could say that it's num rows minus 2, and that j is greater than or equal to 1, and do j minus minus. And then we could say columns sub column sub j equals s sub I plus plus, and then we say column plus plus. So every time we're zagging, we're drawing a j up by, we're drawing at j, drawing the next character at j. And eventually, I think we need to do like some kind of const next. And we'll say like if I is less than s dot length, we'll say return s sub I plus plus. And then otherwise it's empty string. And then we'll do next. Next. That way we don't have to worry about like exiting early. This function will just help us to do things a lot easier. And we could just do return columns dot join with a space and dot map column dot join with a space. Is that correct? I don't think so. It's actually transposed. So I'm just trying to think. I believe that we have, well, the way I'm envisioning it is like this is an array, this is an array, this is an array, this is an array. So I need to figure out a way to merge this into a single string. Oh wait. Oh, okay. I got it, okay. I see. Okay, so yeah, so now I need to go through each element of this double array. I'm actually going to make this empty string. To make my life easier. But yeah, at this point, we're gonna do for let I equal 0, I is less than. So we want it to go column by column first. No, we want it to go row by row. Row equals 0, row is less than num rows, row plus plus, or let col equals 0, col is less than columns dot length, col plus plus. And then if columns sub column sub row then put dot push. Actually, we just push it. It doesn't even matter. Dot join empty string. Okay. Pretty much we zig and zag. We go fill in items for the entire column as we zig, and then we start filling in as we zag. It seems right to me. I mean, it's a little confusing. I think the only way to know is to run it. Push columns row. Reading 0. Okay, well, let's do console.log columns. Row num rows. That's good. Okay. So it might kind of be backwards, upside down-ish, but that's okay. So this should be call. Wrong variable name. Okay. So, oh, it should be row. Wrong variable name. Okay. Let's run it one last time. Excellent. Now, yeah, there's probably a more efficient way. We could submit it for now and just see um, how good we did. We did pretty horrible. Pretty bad. All right, so there's clearly somewhere we can optimize here. So I'm kind of wondering if there is some kind of weird algorithm that doesn't require you to build this string in order to build this string. Or we can cut out this loop here and this join even. I just stare at it for a moment. See if anything jumps out at me. Okay, so one way we could improve performance here is to not have to do these column pushes. So one thing would be to have like a data array. We could say const set row column value. I just want to remind us the percentile we're at is 5%. We beat 5%. So let's try to do better than 5% at least. Let's try to do better than 10% at least in this iteration. So what we could do is we could say data sub row plus column equals value. All right, so if we do that, we can get rid of that. We get rid of that. And we could say set column and next. And then we could do similarly here. And then when we get down to here, actually row is going to be times num rows. So we could try to think about how this array might look. We could think about it, or we could just print it. We're going to get an error, but I just want to see the print. Right? Can't set a function to another value. Okay. Just trying to appreciate whether if it looks a certain way that I'm expecting. The PAAHLNIIG. It doesn't seem to have everything that I'm expecting. Data sub row plus column times num rows. Oh. There you go. Once we can get this to look kind of correct, PayPal is hiring. Okay. The only question is, well, what is the input? 3? Okay. The thing is, we don't know how many columns there are until the end. We know how many rows there are, so we can't really mess with the formula too much. Ideally, Okay, so theoretically, if we knew how many columns there were, we would be able to just join the string instantly, immediately. So my thought is, what if we lied about how many columns there are? Because it would potentially simplify this. I think in order to determine the number of columns, we could num columns. It's fine if we lie. Equals s dot length divided by rows. So like for this one, there's 1, 2, 3, 4, 5, 6, 7 columns, and there's 14. Okay, it's definitely not a perfect solution, but again, we could just lie. And we'll do row times num columns instead. And that would make the string be laid out in a different way. PAHN, yeah. So now that the string is laid out in a different way, and there's going to be way more empties. We have the ability to return data.filter .join empty string. We can get rid of all of this code. We can run this. And it works. But is it better? We were at 5% before. Oh, it just doesn't work. Darn. Okay, so they gave us ABC. The number of rows is 5. The output is AB. Okay. We'll do this, and then we'll say convert ABC. We got undefined. Oh, the undefined was some declaration. Okay. Okay, there seems to be some kind of issue with the console. Maybe that it's frozen. I think I might have broken it. Can't run this code. Weird. Oh, well, yeah. I did indeed freeze it. Which is interesting. Let's pause it and refresh the page, I suppose. Mm. Okay, we're gonna have to, I think, quit for the moment. Probably even force quit. Okay. All right, we're back here. ZigZag. Okay, so something we did likely caused an infinite loop. Let's try running it again. I guess let's think about the scenarios in which the string is much shorter than the number of rows. So I don't know why would infinite loop here. Why would infinite loop in the console but not in the the runtime here? I'll put a break here. Do this console. Put that code and ABC. Okay, so for some reason it's empty, which is strange. But oh, because I didn't put a I didn't do row numbers. 5. And it does give us A, B. And it just very simply never tries to put C. So I don't know why C is not being put into 6. if I is less than s dot length and return s sub. Am I doing I plus plus somewhere else? Am I doing anything with I somewhere else? So then there's row, column. Okay, I'm just gonna print. This is just gonna print it. Maybe I'm overwriting it at some point. Um, do put C. Okay, so apparently during a zig, it gets overwritten. And that, because the number of columns is too small. This could help. In actuality though, I think something like this is required. Or we can go back to this. I think it's basically we're going out of bounds when we shouldn't. We'll do this and this. Okay. We'll get rid of that. We'll run it here. Oh, you gotta get rid of this break. Run it here. Nice. All of them are passing. Let's submit it. Actually, we should have gotten rid of these console logs. They're probably fairly expensive. Yeah, that too. Um, let's run it. Nice. All right, let's submit it. Wow. We didn't do much better. So a join filter is not good enough, apparently. I wonder if there's just like some niche ZigZag algorithm. Okay, well, here's another thing we can. All we can really do is just keep optimizing. Don't call a function. Calling a function is slow. don't do conditions. Doing conditions is slow. And just be excessive here. So let's run this. It works. Let's submit it. Still not much better. This is another place that we're calling a function, and I know that JavaScript isn't really fond of calling functions. I mean, I guess it could have something to do with the filter joint too. I mean, there's probably just like some crazy algorithm that just knows where all the letters goes. I don't think like it's just probably a matter of like one optimization, and suddenly you're better than most. So to some extent, my instinct is telling me to just see what this does. One less function call. Yeah. Interesting. Yeah, it just seems like I have the worst algorithm out there. Okay. Trying to think about it, wondering if there's like either recursion or dynamic programming that can help solve this. But I'll just do it later.